All right, Systems of Equations test part 2. These ones are a little bit trickier today. These ones involve the problems where they ask you about no solutions, about infinite solutions, and then also there's some fraction problems in here. There's also a couple that involve that have x squareds or quadratics in them. I'm going to leave those off the test because we haven't went through the factoring quadratics unit yet, but one of them snuck on there. Anyway, so we'll skip that when we get to it. All right, let's get after it. So number one, it's just a word problem, and it's just a matching problem, so these ones usually don't take too long. Two types of tickets. So we have standard tickets, which cost $12. So I know I'm going to have a $12 attached with a standard. And then the premium ticket for $5. And what is that total? It said total of $2,300. So this is our money equation. So this one was all dealing with money. Well, then you have the quantity equation, all right, the one that talks about the number of tickets. And it looks like we had a total of 250 sold. So we know that the standards plus the premium came out to be 250. So what are we looking at here? And usually they just, like this one, they actually have the numbers in the wrong places. So kind of keep an eye out for that. So I'm looking like B, probably a good answer here. Moving right along. Number 2, right out of the gate, I see that we have some fractions that we have to deal with. So my move kind of always is I'm going to go through and I'm going to clear some fractions out. And I clear fractions out by multiplying each row by the LCD, or the least common denominator, a number that both of those can go into. So on the first row, I think I could multiply by 3 because both the bottom numbers are 3. So everybody gets times by 3, you, and you. And my new row is 3 times 1 divided by 3, so that's 1x. 3 times 2 is 6 divided by 3, which is 2y. And 3 times 3 is 9. The bottom's a little bit trickier because I have a 3 and a 2. So I'm going to multiply that row by 6 because that's the first number they go into. So times every single number by 6, the numerators. 6 divided by 3, that'll be 2x, that'll be 3y, and that'll be 16. So I have a much easier equation to look at. I don't have to look at all those fractions anymore. So now what do we need to do? It looks like we need to solve for x and y, and then we need to actually put x on top of y. So I think the easiest way to get my opposites is going to be multiply this top row by -2. So I'll have -2x, -4y, -18. We are ready to combine and eliminate x's. So I get -y is -2 times both sides by -1. And I get y equals +2. So that's going to go on bottom. Now to get x, I want to substitute that back into one of these equations. I'll use the top one. X plus 2 times 2 equals 9. Or x plus 4 equals 9. Or x equals 5. So the correct answer to this problem is 5/2, or you could probably put 2.5, and that will be acceptable. All right, number 3, again, I see some fractions, don't like it. Let's clear them out. 2 and 4, the LCD would be multiply everybody by 4. So 4 divided by 2, that's going to be 2x. 4 times 1, this is going to be 1y. And that's going to be 1. The bottom, we're going to leave alone. This is kind of one of these weird ones. So what do we need to do? It says the system of equations has an infinite number of solutions. So infinite number means 2 lines that are on top of each other if you graph them. Infinite also means that basically they're the same exact line. So everything will get eliminated. Your x's, your y's, your numbers, everybody needs to get eliminated. So let's try to eliminate everybody. I can't really do anything with A and C right now because I'm going to eliminate my numbers first. So I'm going to multiply this top row by -4. And when I do that, I get -8x minus 4y equals -4. And then I get ax plus cy equals positive 4. I chose that number because I needed to get this 0. Well, now I should be able to see how to get the other zeros. It looks like A needs to come out to be a positive 8. That will give me a elimination. And C needs to be a positive 4. That would give me elimination. So if A is 8 and C is 4, it looks like our final answer to this question is 2. So a little bit tricky here. Just got to kind of know the strategy. So number 4, we have 2 of these equations, and it says that the system of equations has no solution. All right, so when you want no solution, it's similar to the last example, but if you want no solution, that means we want our x's to eliminate, we want our y's to eliminate, but we need to have different numbers. All right, so we kind of want like a 0 plus 0 equals some number, because then it's going to be not possible to solve. So let's kind of go through here, and I can't eliminate y's right now unless I multiply one of these rows. Maybe I'll do the top row. Let's do the top row by -1. So I get negative y equals 3x negative minus 2. The bottom row I get y equals ax minus 5. Well, when we go through and we can now try to eliminate, I eliminate y's. My numbers are not going to get eliminated, which is what I want. But to eliminate x's, it looks like a needs to be 3. So the value of a is going to be 3. So that way I end up with a false statement. And no solution, you're always going to end up with a false statement. You're going to have 0 equals some number, some constant. So it's a little different than infinite solutions where you want 0 equals 0. Number 5, I probably won't put this one on the test because it has a quadratic, but it's actually pretty easy to solve. So I'm just going to sneak this one in here. I use substitution. 2 plus 1 is x squared. So 13 is x squared. And to get rid of x squared and to get x, you take the square root of both sides. And then you need to remember that it's the positive and negative value of the square root of 13. So the correct answer is A. I won't put one like that on the test just because we didn't do a whole lot of those. This one, number 6. I'm going to clear out this fraction on the bottom. I'm going to times both pieces by 2. So I'm going to get x equals 4. And now why don't we just substitute? So 2 times 4 plus y is 14. That's 8 plus 2y is 14. That's 2y equals 6. Y equals 3. They want the value of y, so we are done. Money. Moving right along, number 7. Got a story problem here. In economics, the equilibrium price is defined as the price quantity, demand, and supply are equal. So we need demand and supply to be equal. If they are equal, what is the equilibrium price? So what is P? So let's set these two equations equal. Here's the supply equation. That's supply. And then we're going to write the demand equation. And we need to figure out, when does supply equal demand? What P will make that happen? So I'm going to take away the 15B from both sides. I got 10 P's over here. I might as well just in this same step take away the 100 so I can get my 750s on the other side. Divide, and it looks like that price needs to be $75. That's where the two equations balance each other. Supply equals demands. A little economics going on there. Number 8 we're not going to worry about, so scratch this off. This will be covered in the factoring quadratics unit because you need to know how to do that. And I'm sure you probably had Algebra 2, so you know how to do it, but we haven't went over it yet, so I'll save that one for when I go over it. All right, number 9. A system equation above, C is a number. For what value C will there be no solution? So remember, I want my x's and I want my y's, I want everything to cancel, but I do want a different number. I need to get 0 equals a number. So let's try to first eliminate the x's. So I'm going to multiply by -3. I get a -6x minus 9y, -15. On the bottom, I got a positive 6x, positive cy, and a positive 8. We try to eliminate. Bam, you're gone. You're going to give me -7, which is perfect. And basically what I need right in here is I need that c to be a 9. Then we'll be golden. Then we'll have 0 plus 0 equals -7, which is a false statement, no solution. Finally, number 10, which of the following graphs shows a system with infinite solutions? So, graphically speaking, only 3 things can happen. It's infinite solutions when you graph a line and then you graph the second equation and they're right on top of each other. It's no solution if you graph 2 lines and they are parallel to each other. That's a no solution. And then there is one solution when you graph the first line, you graph the second line, and you do have an intersection point that represents the one solution. So since this problem was infinite, we're looking for the same line on top of itself, which is going to be answer choice C over here. All right, hopefully this little quick review gets you ready for the test. See you.